Welcome to Mooseworks. Today, I'm going to explain to you how I made this vise just like the Fireball Tool Vise, but a little different.
If you want to build this vise, I provided some plans at this timestamp here. I used simple tools, which means you won't need a CNC plasma table, a milling machine, a lathe, and a massive go-kart grinder. Let's get to the good stuff. Now I wanted to use scrap metal for this build, so I used square tubing, angle iron, and 1/2-inch plate that I had on hand. I used hardware that I had from Tractor Supply, 3/4 inch thread and 5/8 cold rolled rod. Now the 1.5-inch pipe and 1/2-inch plate. Starting off with this 3-inch angle iron, I cut it down to size for the static jaw body that I plan to weld together here in a second. And it looks like there is too much of a gap to use 3-inch angle iron. So that required an extra trip to the scrapyard to get a 4-inch angle iron, which was a little big and it was dirty. So I went through and cleaned it up with my wire wheel here on my 4.5-inch angle grinder. Took a little bit of work, but I got it looking nice. So this was the first project I got to use my Porter Band saw from Harbor Freight. So I went ahead and squared off the end here, cleaned it up, and made the cut with the new Porter Band. And now we are in business. So because this is going to be sliding metal on metal, I went ahead and used this belt sander, which I figured out to keep a surface flat and still take quite a bit of material off. You just use a zirconium belt on a belt sander, just like I'm doing here, and it takes a lot of material off but keeps everything flat, so it works out perfectly for this telescoping tube. Now I needed to cut this 4-inch angle iron down to fit that 3x3 square tube perfectly. A lot of grinding, a lot of cutting with the 4.5-inch wheel. The 4.5-inch angle grinder is such a versatile tool. If you're a small shop, you should get multiple ones to use. So you can see here the 3x3 fits nicely in between those two cut down angle irons. So I'm using some coke to create some spacing in between that and going through and tacking those together. Really ended up being too tight that I couldn't remove that square tubing, so I ended up having to cut it out and go back and restart. Now I did quite a bit of research at this point to make sure I didn't end up in the same place, and so I ended up finding JerSchmidt talking about telescoping tube, and he said to use MIG wire. So I'm using this 030 MIG wire right here to get spacing on one single side of each of the angles. It's a little tight, but once I removed that wire, it slid nice right here. So I went ahead and completely welded out the two pieces of angle together. I did get a little bit more weld distortion or pulling down, and so I ended up needing to take a little bit more material off of my 3x3 square. But you can see I got it nice and smooth, and it slides really tightly within those two pieces of angle iron. So now moving on to the actual load plates on either side, you can see I created a hand sketch, and then I'm cutting out some patterns here to visualize, to kind of see the size of it. So I went ahead and got this 1/2-inch plate that I got from the scrapyard and traced out the patterns of my load plates. Using the Porter Band again, this was a perfect project to test it out and put some time under the trigger, I guess you'd call it. And that went rather quickly. It was real nice. Now to get the two sides to match up perfectly, I went ahead and clamped them together and then used a flap disc to grind them down to the exact same shape. They may not be perfect as to what the drawing or my hand sketch was, but they are going to be an identical match from side to side, which will work out perfectly. You can see quite a bit of grind dust there. I'm cutting out the cross blocks that are going to hold the grip plates here. They will get welded into those slots, and I was rushing a little bit and made a pretty good mistake here. I mixed up the 2 dimensions and cut it the wrong way. So here I'm using the porter band to cut a little piece out, move it up and make that dimension correct. So I welded this up, got some good penetration, and then I went through and ground it out flush to make it look like it never happened. And we're good to go. They match up perfectly, and so now I'm going to go ahead and tack those load plates on the dynamic jaw here. I wanted to just tack everything until I got everything fit up together and made sure it was all nice and tight. Tried to use the porter band, but it wasn't quite enough to get that done, so I ended up having to use the skinny wheel on a 4.5 inch angle grinder right there. A little bit of cleanup with the flap disc was required, but all in all it was looking pretty nice. And I went ahead and put those load plates on either side of it. They fit up really nicely, especially with that dynamic jaw. I went ahead and welded everything out. So you can see I'm using 6011 wire here to get some pretty good penetration. Now we're going to move on to the base that I'm going to cut out of 1/2 inch plate as well. All this was scrap metal I got at the scrap yard, so it was a pretty cheap project. Using the porter band again, it really got its use on this project. It really cut quite well. There was one instance where it started to wander off a little bit and I had to change the blade out, but it was good for the most part. Setting it up here, getting an idea of what I wanted. I know I wanted to round the corners off here to keep from hitting it with my hand or my hip. Anybody who's spent some time in the shop knows sharp corners are not good on tools, especially when you're working around them. So I'm going through, I'm grinding out some bevels here to get some groove welds around the base of that, and then I went through and drilled out holes to mount it to my table.
If you're liking the video so far, then go ahead and like the video.
Now the main load pipe, or the pipe that's going to be on the inside, is the 1.5 inch tube. It was super rusty as I got it from the scrapyard as well, both on the outside and the inside, so I needed to go through and clean that up. So I elected to use this vinegar and set it inside the solution for a couple of days to get that rust out of the inside and the outside. All in all, I left it in there for 72 hours. You can see it took the rust off pretty good. I went through and dried it off. It was good to go. I went through and cleaned the ends up where I was going to do some welding, and then you can see right here's my drive nut that the all thread is going to run through. Now in order to get this to fit inside that tube, I went ahead and ground it down to where it would slide nicely in there. I left enough on the outside to put a fillet weld on the outside, and then I'm putting some holes on the end of that tube right here so I could get some slot welds around that nut just to add some strength to the main operation of the vise. In order to keep things aligned well as I weld it up, I put the all thread all the way through and tighten it down with a bolt or a nut on the other side. And once I got everything all straightened up and level, I went through and tacked it up like I'm doing right here. I'm using that old pillowcase soaked down with water to keep the threads clean while I'm welding, just to keep from getting BBs or berries on those. So now we're moving to the back plate for that load tube. This is just going to be a square piece that gets some bevels or groove welds on the back side of that static jaw. You can see here I'm putting those bevels in to get nice deep welds that'll hold this on. Here I'm marking the center of the plate as I wanted to make sure the load tube was centered on it. I drilled a hole so I could use a hole saw to kind of scribe the perfect circle around the center. This didn't work out great. I probably could have done this a little bit differently, but it worked. So here I just made a tack weld. Generally, to get a pipe completely square to a plate, I do one tack, hit it, maneuver it a little bit until I get it square, and then I weld it out like I'm doing right here. Once I was finished with that, I wanted to throw it in there to see the fitment, and it looked like it fit good. So now we're moving to the front plate right here. I cut this out, made sure it fit, and then I'm marking out the holes for the cap screws that are going to hold this front plate in. Since I need to have access to the hardware on the inside and the thrust bearing, I elected to use 1/4 cap screws going into the sides of those load plates. So I needed to drill and tap holes to accept and hold on to that front plate. Now on the last hole, since this is a blind hole, it was a little bit difficult, and you can see I broke the tap. So this was quite a bit of a headache. I tried a couple different ways to remove that tap, and I ended up just having to cut it out with the 4.5 inch angle grinder and then use a grinding disc to open it up. This is a runoff tab that I'm going to weld on the end here. That just allows me to continue the weld all the way out and not stop at the edge of the plate. So afterwards I can cut it off to a really nice 90. Now I'm not a professional welder, I just like to weld as a hobbyist, so it's always nice when you get a good slag peel like you saw there. So I'm grinding this down to just be nice and smooth, as close to what we started with, and I went through and drilled a hole and re-tapped it. Now we're moving to the plate. I bolted it to the front, and we wanted to find the center for that all thread to go through. So I'm using a hole saw here. I cut all the way through, and then I had to file it down for a nice fit. There was a little bit of slop in that. I wish I would have used a little bit tighter fitment on that, but that's okay. So moving on to the cross blocks here, they're going to hold the grip plates. I found these at the scrapyard, and they were just about perfect. I had to cut the ends off to make them fit for the size that I wanted, but they were very close. So now I'm welding the bottom base plate to that static jaw. I really got to practice some welding here. There was quite a few welds. I'm using 6011 rod on this. I really enjoy welding. That is definitely the fun part of this project. Now, because I am not a welder, I like to grind my welds down to where they don't look like welds. Nice and round edges, almost looks like a cast part was really my intention with this. Now at this point I wanted to test out, make sure no weld draw caused anything to deform. Things were fitting good, so I went ahead and put my all thread all the way through the vise right there. Everything was fitting nice with those cross blocks, so I wanted to move on to the handle. Now I grabbed my 5/8 cold rolled bar, and I am prepping it up to make it into a handle. So I'm using an oversized belt here. This is a trick I figured out a few years ago, that if you flip that oversized belt on your belt sander inside out and put it over that part, it will conform to the radius and really cleans it up quite well. Cleaned it up and it's looking nice right there. Now in order to take this handle on and off of the vise quickly, as I want to be able to operate the vise with a 1/2 inch drive, I went ahead and cut a bolt up that I will weld on the end of that rod. I didn't have a die large enough to cut the threads in the end of that 5/8 rod, and I really thought this was going to be the quickest way to do it, and it ended up working quite well. So I'm cleaning that up right here. Again, I'm going to use my belt sander trick to get the final finish on that. And you can see it's really hard to tell where the bolt was welded on. So it looked real nice. Here I'm welding a nut on the one end of the rod, 5/8 rod that I'm using for the handle. And I'm just grinding it down here smooth to look nice to hold the handle on. Now on the other side, I'm using a nut threaded onto that bolt that I welded onto it. I'm going to cut that very end of it off, and then that nut is going to serve as a twist-on kind of cap or stop for that handle. I'm going to grind it down so it is round and smooth like the other side, so you could barely tell a difference. But I ended up having to weld a little piece of metal on the end to keep it from going all the way through and seeing the threads. Clean it up with the bench sander. The two ends match, but you can remove this one side because it is just a bolt. So moving on to the back plate that holds that drive tube, I would put it all the way through the vise, and you can see that bevel ready to be welded there. I tightened everything down so there's a nut on the front with the all thread, and I went ahead and welded everything out on that back plate here. As I was welding this back plate out, it moved quite a bit and got out of center, so I had to cut it off 3 or 4 times and re-weld it. I went through and ground everything smooth like you can see here.
If you want to see more videos of me making stuff like this, then hit that subscribe button and make sure and turn on that bell for notifications.
So moving on to the drive system here, with that 3/4 all thread, I am using some thrust bearings both on the inside and the outside that I got off Amazon. I'll put a link below. I went ahead and cut off that all thread. Now I wanted to protect that thrust bearing on the outside, so I went ahead and cut some tube. You can see this is why I need a vise for this project. I'm having to rig up some clamps there to be able to hold this pipe to cut it to length. So I put a little Coke can for spacing in between that and the thrust bearing and tacked that in. And so I went ahead and welded the nuts on the end of that all thread to serve as the landing place for the actual handle. Ground everything smooth at this point, and then we're going to go ahead and take everything off so we can finish out the welding and grind everything smooth. Here I'm taking off that front plate, just making sure everything fits together. You can see there's a thrust bearing on the outside as well as the inside, and I am using this spring here that I got off Amazon that fits around that 3/4 inch all thread and takes out all the slop in the system. So on the end here, to get nice spacing, I ended up putting 2 washers. This is the dynamic jaw with the front plate right here. This is the farthest I want the vise to close, so that is theoretically the point I want the nut to stop. So I went through and drilled a hole all the way through the nut and the all thread for a cotter pin to stop that nut at that point. So I can take that nut on and off and then just lock it down with that cotter pin. So I disassembled everything here. The 2 washers that I needed to get the right spacing, I needed to cut down and then weld out to get a nice end that I could drill a hole in to accept the handle. And we're actually going to have to add some size to it, as it was a little bit too thin on the sides to put that handle through. So I'm cutting this pipe here. It's actually the same 1.5 inch pipe that I used on the inside load tube. I'm putting a hole here to match the hole that's already been drilled out of my handle, and then I'm going to put it around the outside of that ground down nut, the 2 ground down nuts, and I'm going to weld this tube on the outside. It's just going to add a little bit more material on either side of the handle once I put it through. So now I'm drilling out the hole to the final size for the handle that we made earlier. Doing a little bit of cleanup with some files here, make it nice and smooth. And there is the rod that was used for the handle. So I'm using my belt sander trick, cleaning it up. And we're going to test out the fit here. Put it in and everything's sliding nice and smooth. Worked out quite well. Now I wanted this vise to be able to be operated by a impact driver. Instead of using the other end of the socket, I elected to use the 1/2 inch drive side. So you can see it inserts nicely. That way I don't have to go and find a socket and a drive. I can just grab the drive and operate the vise directly. So I cut that socket down. I went ahead and welded that up, and now you can see me cleaning up the end of that socket, that Craftsman socket here on the end of my drive thread. I inserted the handle and everything was still operating. There's my little workshop buddy. Here are the grip plates, so I'm scribing everything out here. I'm going to cut these with 4.5 angle grinder for the actual pattern of it, but I'm cutting the main portion of it out with the portaband here so we can get a good fitment with these cross blocks. So I grabbed those plates. We need to go ahead and cut a little groove in the cross block to allow for that to rest on. So I went through, I got to grab all my PPE. It was a pretty thin piece that I was taking out, so I had to be real careful. I got a decent slot cut out of there. The fit up was pretty good as it can be, I guess, without a mill, which I do not have. So just using that 4.5 inch angle grinder and a file here, we got a pretty good little cutout for the grip plates, and you can see they fit in nicely there. So moving on to the front plate here, we're going to go ahead and weld it out and clean it up. So it's looking nice. Now we're going to move to the grip plates and cutting out the holes for the cap screws to go into and hold those grip plates to those cross blocks. I'm using 1/4-20 cap screws that I got from Tractor Supply, and now I'm going to go through and drill and tap holes into those cross blocks to hold these grip plates on. So since I already have the holes in the grip plates themselves, I use those as a jig to start the drill marks into the cross blocks to make sure that the drill holes lined up exactly. So I went through and drilled those out, and now I'm using a 1/4-20 tap to tap all the way through those two holes to receive the cap screws here. You can see the first cap screw went in quite nicely. The second side, the cap screw went in nicely as well. So I went ahead and tested out the grip block to see if it could be mounted in here, and it's holding on nice and tight. So we're going to move to the dynamic jaw side. Drilled and tapped the same holes. This is quite a bit of work, but those grip plates were holding on. So here I'm doing just the final cleanup welding. There was a lot of areas that needed filled in or finished out with welding, and so I'm going through and finishing that up. Now, I like to make things look nice, and I plan for this vise to last for years. So I'm going through and cleaning up all the welds here by grinding. Finishing out the grip plates, I'm going to clean them up with the benchtop sander and using a magnet to hold on to them. The grip pattern that I scribed out, I'm now going to use the 4.5 inch angle grinder here to cut those out. Maybe about a 1/16 or so deep into that, just enough to really allow for those plates to grip whatever it is I'm holding. I plan to make other attachments for the vise, but these are the first ones that I plan to last for years since they are made out of that same material as the vise itself. I'm going through and installing these grip plates after all the cutting and everything to check the fit up for when the dynamic jaw and the static jaw close together. When I closed the jaw here, the two edges on top didn't quite match. They were not flush. So I went ahead and grabbed my belt sander with that zirconium belt and I went through and took off enough material to make things match up perfectly. Now I'm going through and using my wire brush on the 4.5-inch angle grinder to clean all the welds and all the surfaces and get it ready to paint. Now before we paint it, we're going to go through and assemble it here and then test it out. So here's all the components. So getting the dynamic and the static jaw together here, I move to the front plate and I take the outside thrust bearings and put them into its little cover there. I slide the all thread all the way through. I put the inside thrust bearing around that all thread. Then I put the spring in and then install the inside locking nut that's going to receive that cotter pin. Once I get it lined up with the hole in the all thread, I put that cotter pin in. And then I install the all thread into that drive nut. Once it's fully tightened down, I go through and put these cap screws in to secure the front plate down to that dynamic jaw. So here I'm using my impact driver with a 1/2-inch drive to operate the vise in and out just to check how it's sliding. So now I'm taking the handle, taking that one end off to easily install it into the front of that vise to check the fit up, see how it operates. The operation of the vise was very smooth. There was a little bit of slop when the dynamic jaw was opened up all the way here. I'd say it's about a 1/16 of an inch, and it goes down as you close that jaw. It's really pretty good, and it's a lot better than the vices that you typically buy on the market until you get up into the higher end vices. So I'm going to take some dimensions here, the main one being this 11.5-inch of opening that the jaws can open up to, and then 6-inch on those blocks. A few other dimensions here. You can pause the video and look at those if you would like. So I'm going to go ahead and mount this vise up to the welding table here. I made this welding table 2 years ago out of 1/2-inch plate. I did upload a video of the full build, which you can go to if you click here. So using these 4 1/2-inch bolts, I secured this thing down pretty tight. So I'm going through and doing a little testing here. So here's the first thing I'm going to test. Is just a piece of wood. I'm doing it by hand, and you can see it squishes it down pretty good on that 2x4. Now I'm really liking the jaw capacity in this with that 11.5-inch opening. I'm going to go through and put this 6x6 square tubing that's a 1/4 inch thick into the vise and really see what this thing can do. So moving it by hand, it's pretty easy to move, especially since we're bending metal here. I think it's going to be a real good vise that I'm going to use for years. It does take a while with the 10 threads per inch on that 3/4 all thread to operate, which could have went with an Acme thread to improve that. However, I am going to get a higher clamping force with that lower threads per inch. I'm super happy that I put that 1/2-inch drive in the end of the main drive thread there so I can open and close the vise with the impact driver or a drill. I'm going to do one last test here, a little bit of a show to show you what this vise can do. Now I was happy with the vise, so I went ahead and prepped this thing for paint. So I'm using this automotive primer that I think is going to adhere to the steel quite well. I went through and covered everything up. I made sure to tape the areas that I wanted bare metal to either show, or if there was any metal to metal contact, I wanted to make sure and not have any paint between those two surfaces. I'm using some oil-based enamel paint here, specifically made for tractors. The color I'm using is called Ford Red, and I got this paint from Tractor Supply. The red color is going to be nice. It's going to pop out in my shop, really look nice. So I let it dry for a couple of days, and you can see here the paint job looks very nice. I wanted to provide you guys with the prints or the plans for this vise. I went ahead and drew this up in CAD after I had built it so I could put together some plans to show you guys how to build it as well. So here I'm going to display each of the prints or the plans for about 2 seconds on this video. You can go ahead and pause, take a screenshot, or take a picture with your phone if you want to try to build this vise as well. I'll put some links in the description as far as the hardware that I used. I'm super happy with how this vise turned out, and I know I'm going to get lots and lots of years of use out of it. Thanks for watching. If you liked this video and stayed all the way to the end here, make sure and hit that like button. And if you want to see more content like this, go ahead and hit the subscribe button. You can click the video here where I built the welding table that this vise got mounted to. Thanks for watching, and happy fabricating.